Okay, so it's been a long day. Thank you all for still being here, basically. I'm going to be talking about a case study today. Let me first quickly introduce myself. I'm a developer, speaker, trainer, consultant from the Netherlands. It's my first time in Moscow. Great to be here. If you want to reach me, you can Twitter me on that handle. During the talk I may not respond, but after I will definitely. And I work for a small Dutch company called 4Scouts. Now, as this is a closing keynote, I want to wrap the day up a little bit. So I spent the day listening to a few talks and listening to or seeing slides and hearing the other speakers talk about what motivates them. So I believe we talked about punch cards early in the morning. We talked about floppy disks early in the morning. We talked about microservices. Who here loves microservices? Good. We talked about startups. We talked about data analytics. There was even a slide about security or two. There was some agile talk. And there was some DevOps thing too. And there were SecOps, and there was QAOps, and there was more stuff, and there was more stuff, and adding it on to DevOps all at the same time. I noticed that the battery of my clicker is dying. Anyway, that was today. But what I want to talk to you about really is something that happened a year and a half to 2 years ago. In a beautiful place called Amsterdam, near the river which runs through Amsterdam, much like the Muskva River, this is called the I River. Splits Amsterdam in two, and there was an office right next to the river. Very beautiful view. Now, this company that I was consulting for had an aging monolithic system, as a lot of companies do. Not a very unique situation, which happened to generate significant amounts of money every month. But it was also dreadfully slow and very complicated. And there was a lot of technical debt, bless you, in that particular system. Now, the team that was dealing with this system, they were doing manual releases every 4 to 5 weeks or so. And the problem with that, this product was a job site where people can log in and get a better job or find a new job. And a job site like that has two groups of customers. On the one hand, you have companies that are placing jobs on that site, and they typically do that from 9 to 5 on the weekday. And then there's, well, basically you and me looking for a better or a new job on that site, and we typically do that at night or in the weekend. Now, the manual releases typically happened on the weekend, and that means that it directly interfered with people that were looking for a better life and a better job. So that was a problem. The site went down for a number of hours every 4 to 5 weeks. The team had fragile tests. Tests that were falling over randomly from one build to the next. You may see different tests failing and other tests succeeding. Frequent issues, frequent firefighting, a system going down, not just after release, which happened frequently, but also during the weeks of development. And, excuse me, as a result, the team had low velocity, low motivation because of what they all were fighting against. And there were a few problems, of course. The business started not trusting development anymore because they were so slow. Development started not trusting business anymore because they were asking the impossible, a standard situation that continued to deteriorate. Now, the business set or the management actually had a few goals. And the first goal of that is improve quality significantly in this system. And the second goal, reduce time to market. Because when they were doing this, because of the low velocity, because of all the issues, simple features took months to develop and release to production, rather than simple features should be taking days or weeks to go to production. And in a market as competitive as the job site, I mean, there's LinkedIn, there's Indeed. Well, I think LinkedIn is blocked in Russia at this point. At least I couldn't access it today, but still. There is LinkedIn. So there's a lot of competition in that market. So when you have a feature which takes 3 months to go to production, that's simply not acceptable anymore in 2017 or 2016. Now, when you set these goals, 2 questions can be asked. Do we refactor the current system, the existing system, or do we rebuild it from scratch? Refactoring was tried initially, very enthusiastically, I might add, and after 3 months, the team had 2.5% code coverage. Which is, in relative terms, is an insane jump, going from 0 to 2.5%. But in absolute terms, it would simply take too long and cost too much. And when I say rebuild, I say something called the cut-over rewrite, where we have system A on the left and we build system B, and up until a certain point where system B is good enough, or let's say has the exact same features and functionality as system A. And then we flip a big switch, which never goes wrong, right? And then we have system B in production. Now the problem with that is that you tend to rebuild all the bugs and all the weird issues and weird features that were part of system A, even though they may not be useful or required anymore. Some people have left the company along with the knowledge. Some decisions were never recorded, the why is lost, and some bugs actually turned into features over the time. So that was out of the question. And now with saying no to both questions, so then the next question is, what did we do then? Well, I'll show you. We took an API first approach. This job site, the customers, or rather the recruiters in the company that place jobs on this site, they could do that through APIs. But those APIs were always a second-rate citizen, second-class citizen in this system. We were never considering them as much as the front end. So we turned it around. And we started going towards a service-oriented architecture. Not microservices, but just services. Small enough to be workable, but big enough to actually mean something, to actually have some functionality. And we orchestrated them around the domain objects or domain terms like a job and a job seeker and a company and things that actually mean something in the context of a job site. And then we started, because this is a website, to migrate individual pages from the old system to the new system. And when I say that, I mean something called the strangler pattern. The strangler pattern starts with a monolithic application on the left of the screen, and you see it's connected to the internet and it's connected to some database, very standard setup. And then we start adding, I start adding new batteries to my clicker, that's what. We insert a proxy in between the internet and the monolithic application. The proxy initially doesn't do anything, it just passes the traffic from the monolith, from the internet to the monolith, and then we start adding a new service, which may or may not have its own database, and then we add a rule to the proxy that for a certain piece of functionality, for a certain page, we route the traffic not to the monolith, but to the service. And then we add more services and more services until all those services have enough functionality that we can turn the monolithic application off because it's not serving any traffic anymore. This is what we call the strangler pattern, which is based on a tree which actually grows on other trees and grows around the tree until it kills the original tree, which is a little bit morbid, but that's what we want to do with our monolithic application. Now, in terms of architecture, we said a few things as well. Every front end is a service in its own right. It exposes an API, which is consumed by a browser, but it's still a service. And we want to deploy it and treat it much the same as all the other services. All the services that we have are going to be put behind load balancers so that we can ramp up and ramp down as traffic dictates, as load dictates. but we can also replace individual instances of that service behind the load balancer, and no one would even know. That gives us zero downtime. And third, we do everything as a container. And this was in the relatively early days of Docker, but we were confident enough to have that working. Now, in terms of process, there were a few improvements to be made as well. And all these improvements were discussed and agreed upon by the entire team, not just external consultants like myself laying down the law. Continuous everything, rather than thinking in terms of projects, we are thinking in terms of products. And we are not thinking in terms of a start date and an end date, but rather a continuous improvement or a continuous cycle that goes on daily. Not just in the way we develop, but also in the way we work. So we improve ourselves much as we improve our product and our software. And continuous everything, to me, starts with continuous integration, which I think is a term that was coined today a few times, or talked about a few times. It's an older term, and we start on the left with a developer checking in some code to GitHub or something. And when that happens, that developer then, or the system, the process, then checks out that code and starts running a build. And depending on the language you're in, it may be a compiler or not. For example, Java uses compiler, but PHP doesn't. But there may be other things going on as well. And then it runs some tests. At the end of this process, you end with a uniquely identifying artifact, just one, that identifies that particular build. But that's where it stops. And then moving on to continuous delivery, where we take that artifact and we automatically deploy it to an acceptance environment. On that environment, UAT or other persons, QA or whatever, can test, and at some point we'll say, okay, this build is good enough to go to production. And then it should be automatically deployed to production. It should use the exact same scripts and stuff like that were used to deploy to acceptance. However, hence the red arrow, it will be a human deciding when that happens. And then the third is continuous deployment, which is what I like to do most, is where we remove all the humans from this particular pipeline. So we deploy still to acceptance. I start to call it staging at this point because there's no human acceptance going on. And when we run a few automated checks there, and when they pass, we automatically deploy to production. So that means that there is no human doing any checking. All the checks are in an automated way, and when all those checks pass, we deploy to production. My personal view is that this should happen in 15 to 20 minutes, tops. From pushing to GitHub or your Subversion or whatever VCS you have, to the last deployment on production, 15 to 20 minutes. Some people have other standards there, veer more towards the 1 or 2 hour side, but I have a little bit stricter requirements. Now, this means that every commit that you make and that passes the test goes into production. And why would we do it? Well, I'm a little bit of a masochist in that if it hurts, you do it more often. And the thing with deploying software is that companies that don't want to take risk deploy very infrequently. So in the Netherlands, for example, there are banks or other institutions that deploy once or twice per year because they don't want to have all that risk with deploying more often. And the paradox there is, the more infrequent that you deploy, the riskier each deployment becomes because it's going to be this huge list of changes. And if you do 3,000, 4,000, 5,000 deployments per year, 50 deployments per day, whatever, then every single deployment is going to be uninteresting. So if it hurts, do it more often. And if every commit goes to production, that means we have small steps. Commits should be small. And they go to production immediately, which leads to early feedback. If our pipeline takes 15 to 20 minutes, then my commit now is in production in 15 to 20 minutes. So I can immediately see on the site, on my product, what is happening. Do people, are click rates going up? Are click rates going down? this is the things that Netflix, for example, does at a seriously large scale. And if it doesn't work, then we revert the commit and it's out. Rather than waiting for the release somewhere in the next few weeks, time to recover is reduced markedly when you have a fast pipeline. If I have a 15-minute pipeline and I make a mistake now that takes a site down, then git revert head, commit that or push that, 15 minutes later everything is back to normal. So my time to recover becomes very small. So my site as a whole, or my system as a whole, is becoming more resilient because of that. And last but not least, I mentioned that with Netflix a little bit, this all leads to experiments. I can push a change now, see it happening in production a few minutes later, and I can see what it's doing to my live traffic, to my live users. And that's very interesting to have. When I say every commit goes to production, I believe strongly that that implies that we should do one thing and one thing only. That is, using one branch and one branch only. And it may be called master or it may be called trunk, but it means only commit to master. And yes, dear folks, that means no branches. No branches really. This is typically the point where people start lobbing tomatoes at me or throwing pitchforks, looking at me funny, laughing. I see a couple laughing, I see a couple nodding. But bear with me. This is one of the things that can happen when you use branches. And this is just but one example. But the bigger thing is, branches delay integration. And the funny thing about continuous integration is that the rule there says that you need to integrate with the main line, so master or trunk, at least once per day. And that means pushing your code into master and not merging master into your code, which is what a lot of people think. And if you're using branches, who here uses branches, by the way, during development? Cool. Who here has branches active for more than one day? Okay, so that's, and the rest are have branches that are active for less than one day, yeah? Okay. So if you have a branch that is alive for longer than one day, you're not integrating with the main line every day. That's simply impossible. And the longer you let a branch stay alive, the cost of making that branch merge with the main line is only going to increase. Which is a funny thing to see. If you have a branch that is alive for a few weeks and getting that to merge is going to become very hard. And then there's a bunch of code added to the branch to make it merge. So instead of removing stuff or making it easier, you're actually making it harder. So it becomes like this moving target that's moving away from you. So conflicts. Who here has ever had a serious merge conflict go wrong? Don't lie. Don't lie. Yes? Okay. Minus yours, use mine, of course. No, I've had one project where a merge was so complicated that we couldn't figure out what was where and where it came from. And we tried to figure it out, but weeks later we still found stuff that broke because of the merge. And this is a merge conflict, and merge conflicts can be solved by talking to everybody and reiterating all the work you did. But the more interesting conflict is that of the functional conflict, where you have two feature branches in parallel being developed on, and then they merge, but the two features were never tested together. They may merge together, but they were never tested together, how they interact with each other, how the user interacts with them. Now, some people use feature branches for functional separation, which I think is not the way we should do it. For example, the PO says this feature branch can only be merged at date X or after feature A. The better way to do that is something called a feature toggle, which is essentially a glorified if statement in your code, which allows you to decouple the deployment from the release. And to me, the deployment is something that a team should always be able to do, any time of the day. And the release is something that is a business decision. So a release can happen on a particular date or after something else was done. And a release means that people get to see it. So what does a feature toggle do? On the left side of the picture, we have a search page on the job site I was talking about. This is the old version, and on the right side we have the new version. Now, the new version took about a month and a half to develop. We had new technology, we had a new indexing system, we had a new data model, all that stuff. If we had stopped deploying for a month and a half, that would have made one serious merge, that's one, and two, it would have gone wrong pretty quickly. Plus, we would never have the benefit of verifying early results with some test users. Now, the feature toggle allowed us to do that. So we put a big feature toggle around this search page, and then at some point we enabled the feature toggle for people on our own company network. And they saw the new search page, and we got some feedback. Move this there, and this doesn't work, etc., etc., etc. And we started doing multiple deployments. This took about 1,000 deployments all together. And then at some point we were confident that, okay, this is cool, this is good enough to see the world. So we set the feature toggle to 10%, and we started looking at the metrics of the site very carefully. And when they did not worsen, or they did not go, instead they went up in this case. And then we set it to 50% and then 100%. And then the feature was live. What you do need to be careful about is something called feature toggle debt, which we found out the hard way. If you have a number of feature toggles in your system, then the amount of combinations grows exponentially, of course. So you need to be careful that you keep a limit on the number of active feature toggles, and that you actively manage them by either this is going to go to 100% and then we remove the feature toggle, or it's never going to go to 100%, then we remove the entire feature and the toggle, just to keep a lid on that. Now, who here uses branches for code reviews? Okay. Pull requests are branches, and pull requests are a nice feature in itself and work pretty well. But I want to coin an alternative, because a pull request is asynchronous. You write some code and then you submit a pull request, you pull somebody else out of their work to review your code, and that goes back and forth a few times, and then at some point it's going to be merged. Plus, the bigger a pull request, research has shown, the less likely it is that people will actually look at it carefully. So if it goes beyond 100 rules or 100 lines or something, people will just scan it and say, okay, this is good enough, merge. At which point the whole point of the pull request is moot, right? So what I want to introduce is something which is 19 years old or 20 years old, from the extreme programming book, pair programming. Maybe not like that. Maybe that's not the most effective way of doing that, but still, pair programming leads to continuous inline code review. So instead of having those people smeared out over time, you put them together behind the keyboard. That leads to better quality code. It leads to improved development. It also leads to knowledge transfer. You put somebody with a little bit less experience on something together with somebody with a little bit more experience, and that knowledge gets transferred. Somebody with more ops background pairing with somebody with more dev background, and then you get that knowledge transferred. So that's very interesting. Now, I talked about pipelines a little bit, and technically a pipeline is all about connecting the dots. It's all about tying the individual parts together. And it's about automation. I always say I want to automate myself out of a job. Unfortunately, that hasn't happened yet, but I try to, because automation keeps us from doing repeatable things, and humans are not very good at doing repeatable things, because we get bored, we get tired, we get sick, we get drunk, we get hungover. So you will see variations with us doing repeatable things. So, and a script doesn't do that. So automate as much as you can. That's the whole point behind, or one of the points behind the whole DevOps and CD philosophy. Automate as much as you can. And when we talk about automation, continuous testing is a big part of it. Because continuous testing in CD land leads to confidence. Confidence that the change you make now in your system is not going to blow everything apart. Confidence that the change that your colleague is making right now is not going to blow it apart, and you can continue to commit and make changes together all at the same time and have that incremental iteration there. When it comes to testing, I'd like to talk about defense in depth. Defense in depth, start with unit tests, such as JUnit or NUnit or whatever your particular favorite language is. There's solutions for pretty much everyone. We test individual classes, small classes and everything. Around the class, we mock away. So those tests are small and run very fast. Then we can build up to the integration layer where we actually test components or modules. We may use an actual database to test. We may use data fixtures so that we have data that we know and that we can predict the outcome. Then we have acceptance tests, which are generally written in the English form of given, when, then. Given the world is in a certain state, when something happens, then I see an outcome that I can observe. These stories or these scenarios are written by business experts together with developers and testers before any development starts. And then, last but not least, we have the UI test level, like Selenium, Cypress, things like that. Because they are slower and more fragile, they are at the end of the stack. And if we turn that around, we have something called the testing pyramid, where at the bottom you have the fastest tests and the cheapest, and at the top you have the most expensive and slowest test. So smoke tests are basically health checks or verification checks on a running system. And by that definition, they are the slowest because they require a system to run. And don't forget monitoring and exploratory testing. Exploratory testing is something that QA persons can do from time to time. They log onto the system and they actually test the critical parts of the system, whether they still function as they should, and whether some of the tests need to be adjusted. Maybe some of the tests can be deleted. And monitoring is an oft overlooked but very important part of continuous testing, because there is no continuous testing system that covers 100%, that is completely watertight. Some things you only see in production under load at a certain time, and you want your monitoring system, your alerting system to notify you that that's happening. Our exceptions, number of exceptions per minute is going through the roof. Our response rates or response times are going up, stuff like that. The important thing to keep in mind with continuous testing is that good enough is good enough, because we want to have a pipeline that is reasonably fast and deploys to production in a reasonable amount of time. And we, of course, can keep adding and adding and adding tests, but that will only slow the pipeline down, and it won't necessarily add as much value. Somebody who talked about this a lot said to me, we have a beta program for our users, for example. The beta program is used for early warning. You invite a certain group of people, which are heavy active users on your site, and you say, do you want to be a tester for me? Do you want to be a beta program? Those people will feel honored, they will feel happy, they will feel involved because they're asked to do something because they're such a heavy user. And they will also very actively tell you when something is broken on your site, when something is not correct. And you can even show them new features and get their feedback. So that would be part of a testing system as well. So your testing strategy needs to be good enough for the project you're developing, for the product you're releasing, for the industry you are in, for the regulation you are encountering. So a bank will have a different testing strategy than a job site. And a job site will have a different testing strategy than a Facebook. And so depending on the industry you are in and the things you can get away with, that's what influences your testing strategy, because at the end of the day, the speed of the pipeline is key. Now, I want to talk a little bit about how we deployed in this particular project. This is just one way of deploying, and I think a number of other ways were talked about today. we did something called the rolling update. The rolling update starts with a landscape where we have multiple replicas of a service, the same service, behind a load balancer, and they're all version 1.0 in this example. Now, we just released version 1.1, and we start deploying that. So what we do is we boot an instance of 1.1, and when it's done starting up, we add that to the load balancer and we replace it with one of the old versions. So we take one of the 1.0 instances out of the load balancer, we put the 1.1 instance into the load balancer. And we repeat that for every single instance until we have replaced them all. And at that point, we are all at version 1.1, and hopefully the people visiting the site will not have noticed a thing. Now, if something were to go wrong, it would typically happen here. So we boot version 1.1 in the first replica, but it fails to start. At which point we simply do not add it to the load balancer. We keep the situation as is, and we investigate, we run a new build, and then we continue. So if it fails there, then there's no problem because we still have all the replicas of the old version intact in the load balancer. And we use Jenkins in this project. Jenkins has a powerful concept called the pipeline as code, and it looks a bit like this. A DSL where we write in terms of stages. And the stages are sequentially, so they go from one to the next. And if one of the stages fails or breaks, the other stages do not execute. So the build immediately fails at that point. Inside the stages we have commands, or in this case a bunch of shell commands, but it can be basically anything. And so we run tests, we build a Docker image, we deploy to staging, and then deploy to production in that sequence. And if one of the stages fails, the build breaks. And you can view that in the pipeline plugin as well. You would see the amount of time spent per stage, per build, and also the average times. And if one of those stages again were to fail, this would color red and the entire build has failed. Now when the build has failed, you want to know that very quickly. So that's where we introduced this little siren. It's an LED lamp with a speaker attached to it that when the build fails, we send out some obnoxious little sound to the entire team to alert them that the pipeline is now broken. And when you do CD at this scale, the pipeline is the only thing that's going to deploy to production. We don't do manual deployments to production anymore. So if the pipeline breaks, that means that the entire team is now inhibited, is now blocked. So that impediment becomes an immediate priority thing to work on. Because you as a pair may have broken the build, but one of the other pairs is directly influenced by what you just did. And we don't blame it. That's not productive, not effective, but instead we want to be notified when the build is broken so that we can immediately fix it and continue. We also use the Slack notification plugin for that, but this is much more effective. Right, closing off with some results. Initially, the acceptance of the team that was there at the company was a little bit low because we introduced this whole new way of working. A few people had been working there for 8 or 9 years, and we're like, okay, this is the next batch of external consultants that's going to tell us how to do things, and we've been doing the same thing for the past 8 or 9 years. What's wrong with that? But by actively working with them, we actually, one of those people turned into a champion of this particular way of working and is now giving talks himself. So that's a very interesting result. We talked about feature toggle debt. We did not have a hard or a soft cap initially, which means that we had a whole bunch of feature toggles which were in various stages, 30, 40, 50%, some of them at 100, and we had to spend some active time to get that to reduce. So working directly with the product owner to, well, pressure him, push him a little bit to either push it to 100% or get rid of the feature entirely. Third, at this speed, when you are doing continuous deployment to production and we are thinking of delivering features not in months but in days, the rest of the business better keep up. And that's an interesting problem to have. Rather than now being too slow, you are fast enough, or maybe even too fast for the business. So it means that they, in terms of thinking about features, they need to move up to that particular speed as well. Fourth, I'm afraid to say that this legacy system is still in production right now. I think it's serving about 20% of the traffic, and it's been in this situation where we have two systems now for 2.5 years. But I think, so that means that the focus on replacing that legacy system could have been a little bit better. What went very well? We significantly reduced the number of outages and issues on the site. We had a build time of under 10 minutes per service from check-in of code to deployment to production at 50 plus deployments per day over all the services. The audience metrics and statistics improved massively. We had 20 to 30 to 40% improvements on SEO ranking, on time on site, click-through rates, revenue, not unimportant. And fourth, the confidence, velocity, and fun of that particular team. We had 16 people there, of internal people. That improved very much as well. Now, if you want to talk to me after this session, I'll be here obviously for the next few hours or so. But you can also reach me on my Twitter there, or send me an email. And these two sites, I keep a personal blog there for my company, For Scouts, but also for other things around DevOps, CD, event sourcing, stuff like that. So please send me a message if I can explain or help you with anything. And I want to thank you so much for your attention and having me here in Moscow. Thank you.
Thank you very much.